Welcome to Spring LIB.
Okay, so in this problem, first of all, let's actually try to compare what torque and moment of inertia is in terms of linear motion. Then it will be clear to understand how to solve the problem. So in linear motion and in uh, angular motion, so in linear motion, or let's call it rotational motion, or angular motion. So in linear motion, a force is equivalent to torque in rotational motion, and mass in linear motion is equivalent to moment of inertia in rotational motion. Similarly, acceleration is equal to alpha in rotational motion. Now, for our case, if we want to figure out the torque, we have to apply the following equation. So the summation of all torques will be equal to I, or the moment of inertia, times alpha. And in our case, we are given the final speed. So similarly, speed is equivalent to angular speed omega. So we're given the initial speed, which is 0, and final speed, which is 400 rev per minute. So we can figure out the alpha, or the acceleration, from there. So we know that let's call omega 0 as the initial angular velocity, which is 0, and then let's call omega as our final velocity, which is 400 rev per minute. And if we convert that to radians per second, it will be 400 rev per minute, and then we multiply that with, let's draw a boundary there, yeah, multiply that with 2 pi radian per rev divided by 60 seconds per minute. And from there we get the angular velocity as 41.9 radians per second. So the acceleration will be the final angular velocity minus the initial angular velocity divided by the total time. So since the initial velocity is 0, or initial angular velocity is 0, so we'll just have 41.9 radians per second divided by the time, which is 8 seconds. So that's our alpha. We'll do the calculation later. First, we need to set up the equations first. So since we need to figure out the torque, and we're given the moment of inertia of the flywheel, so from there we can find out the torque, which is I times alpha, and I is given as 1.60 kg meter squared, and for alpha we have 41.9, so we have 1 there, radians per second divided by 8 seconds, which gives us the torque as 8.38 Newton meter. Thank you.